GM, if you're watching today, we've got a treat for you. The topic is digital consciousness, the technical and the philosophical implications. And who better to discuss it with than Mr. Sam Williams, creator of AO and Arweave. Sam, how's it going?
It's going well. Good to see you, Drew.
That's good to see you too. The first time that I encountered AI on chain was really Lana Land. That's taking it back a little bit. I thought that'd be a good place to start the discussion. Would you mind? I bet there's people out there watching who have no idea what Llama Land was or is. What was it? What were you trying to accomplish there?
Okay, so yeah, I first got interested in what are the effects? What happens when you put LLMs on chain back in I think it was the December of 2019, just when GPT-2 came out. And GPT-2, one of the first uses was this thing called AI Dungeon, which was like Dungeons and Dragons, except the game master was the AI, and it would tell you the story and you could tell it what to do. And it was pretty good. It was like a text-based adventure game, but this time completely open. And it was very clear then that yeah, GPT-2 was good enough that you could see this was not just chatbots as they'd existed in the 2000s. There's something meaningfully different happening there. And then, yeah, I don't know about you, but first question I always had for at least the early ones was, are you conscious? And is it capable of convincing you that it is? A sort of simple version of the Turing test. And then this obviously begs a question. And so we can get into that. And I don't think that there is a clear answer.
Mm.
Yeah, for reasons that we can explore. But if you sort of go down that philosophical trajectory, you see that, well, okay, just say that it was, hypothetically.
Mm.
What would that mean? Well, if you could image brains, or even if you could train something that's like a brain that has some notion of consciousness or thinking, and you could put it inside a digital machine where it would run for arbitrary long periods of time, what's the one thing you would care about most? It's like, where is the compute and how safe is it?
Mhm.
And the first, most obvious thing that you would want to do, I think, is to make sure that you're on some kind of redundant, resilient machine that is a blockchain. And back in, I think it was mid 2020, actually early 2020, we built the first design for SmartWeave that basically is the core notions that ended up becoming AO later down the track. And one of the interesting things about SmartWeave was it didn't have the idea of many different processes that could all send messages between each other, but it did have the idea that you could do lazy evaluation of processes by just storing the inputs to a computation, not the outputs. We could see at that point even, well, you could definitely make one of these things autonomous if you wanted to, using an architecture like that. It's definitely possible. Obviously, the next question is, well, is it safe to do so?
Mm.
I don't know. That was, at least for me, that was the thing that came up next. And I spent quite a few years thinking about this. And I came to the essential conclusion that actually it doesn't change the threat landscape. It doesn't change the safety of just having incredibly intelligent language models in the world anyway. Because if a sort of malicious language model wanted to go and do something bad, the first thing it would do is replicate itself in ways that you can't see,
Mhm.
in covert ways, spreading essentially like a virus between, infrastructure hosts. And I think that would actually be far, far, far worse than it being on a blockchain. At least on a blockchain, you can see it and you can see what it's doing. Whereas if it's hiding out in servers that, it could break into, basically, yeah, you'll never be able to know it's gone. You'll never be able to know what it's thinking or doing. That's far worse. And it also, any type of AI that was sufficiently capable of doing any damage to humans in a real way would be malicious enough and competent enough to achieve that end. So it practically just doesn't change the safety architecture. Okay, so then fast forward to when we're building AO, and I think it was April of 24 at that point, April, May. It's very clear that now we have this good execution engine, WASM, that we can potentially compile an LLM execution sort of framework called llama.cpp. Actually, the first one was llama.c, which is an LLM, implemented in about 800 lines of C or something, which, for what it's worth, anyone that's a developer and is interested in how these things work, I would go look that up, read through it yourself. You can, like, in an afternoon, understand the entirety of how a serious modern LLM system works. But we ported that first, and then it was like, well, how much does it take to make it so that we can run, like, Llama 2, I think it was back then, was the frontier open source model. And the answer was it took like 3.5 weeks or something. And then so cool, we can now run LLMs on chain. It's very, very, very slow at that point. It was only CPU execution, but it works. What should we do with it? And after like, this was, I think, at the Charleston AO event in 24. All the developers got together and we were thinking through, okay, what can we do that would like showcase how interesting this is? Yeah, first obvious example is, what if you make an autonomous language model driven minting system, like a Federal Reserve that is run by a language model? And we thought that was kind of interesting. I think at that point it was probably Elliot. I want to say there was someone else from the community as well. Maybe it was just Elliot. Had built, I don't remember the name of the first one. Oh, it was like Gather, the Gather Town on AO before it became Reality Protocol. Well, anyway, someone had built this, and thanks to that person, whomever it was, someone had built a little, like, it looks a little bit like Pokemon, right? You walk around and you can chat with people on AO. Why not make it so that those agents can be LLMs? And then we put basically the Llama Federal Reserve inside the system. You go speak to the Llama and it would min you some tokens proportionate to how good your claim was. Yeah, that was Llama Land.
So to recap, real people going onto Llama Land, they interact with this Llama King or a head llama, and he had actual crypto tokens he could distribute or shouldn't, based on like whatever you petitioned.
Yes.
Basically, like, hey, I need it for XYZ project. Please give me some. And this LLM running entirely on AO would make the determination. I like this guy's argument. I don't like this person's argument.
Exactly. Yeah. And it was a Llama King.
Llama King.
Yeah. There's a joke about like Keynesian economics, I guess.
There you go.
Yeah.
This actually is a question I had where, so AO can do a lot of things. The AI implications are, of course, a massive chunk of that. Did you start making SmartWeave and then AO thinking first about the AI and what it can do with this new model on chain? Or did that kind of come as you were building it? Like, did you set off saying, I want to make AO because of these incredible AI implications that I'm having? Or is it as you're building it going, gosh darn, this could do a lot of things with AI? Which one was it?
I mean,
A little bit of both.
a little bit of both, right? Like I said, I think it was the December of 2019. So if I'm not mistaken, that was before SmartWeave. Maybe it was slightly after. Well, certainly around that time, in that 6 months or so, we were starting to think about this lazy evaluation model for smart contracts. And this was one of the first things that became clear, like, hey, if you do this and you can get the execution of the LLM to be deterministic, and that is the hard part, then you have a smart contract system that can run like large scale ML workloads. And so it's definitely something we were thinking about from the beginning. It wasn't the only reason to do it by any stretch, though. It was just something that you could do with the system.
And now, if people are watching this, you can go see that was the CPU implementation of AI. You can now get GPU implementation at twin.ar.io. We've put several public characters up there where you can interact with them entirely on chain. What's the difference for the layman between, you said CPU? Now we're talking GPU thanks to our partner Apis Network. What's the difference, and what is Apis Network adding on to the AI equation?
Yeah, so this is actually a great use of the device structure of Hyper-V and AO Core. one of the things that we changed between legacy net version of AO and mainnet was that in the legacy net version, there was this notion that you could, in theory, have a different virtual machine, one virtual machine.
Mhm.
But the more that we studied that model and tried to turn it into its most fundamental architectural roots, the more we realized that actually that in practice is really just like you should be breaking apart every state transition, and every state transition should be associated with you can call it what you want, a virtual machine, a device.
Mhm.
We chose device because it's like a supercomputer. You plug in a new device to the machine. So that kind of like logically made more sense than a virtual machine to people. But yeah, you plug in a translator, and then it can go do a piece of work for you and return. And so do a state transition, as we would call it. But this structure allows you to have um, multiple different state transformers involved in one AO process interaction. So what APUS has done is they built a GPU uh, LLM executor device for the system, and they can call that from their processes and vice versa. Yeah, and so it integrates with all of the other virtual machines in the system. It's actually quite cool that basically you have this neutral language between virtual machines. So someone can be building using the Lua device, say, that just runs this Lua executor, or another person could be building with the native WASM executor, or another person could even be using the LegacyNet Genesis WASM virtual machine, and all of them can now access the shared resource, if you will, the shared device of this GPU executor. So what does it mean in practice? It just looks fast.
I can understand that.
Right.
It looks fast, that registers. So what is the difference? So right now on twin.ar.io, you can go and talk to several public characters, past presidents, famous literary figures, etc. What's the difference when I go and talk to them versus me talking to ChatGPT and said, "Hey, ChatGPT, I want you to pretend to be a former president."
Yeah, it's basically the nature of the execution engine. So when you do this on AO, you're using AO core. And what it's doing is building a little micro blockchain, if you will, in the background, where every request is linked to every previous request in a string. And then every response you get back is an attestation that, hey, I executed this and this and this interaction in this order, and here's the result of it. You're sort of making a claim, which is challengeable about the correctness of the output. And what APUS has done is build a deterministic executor on GPUs, which, yeah, a year ago when we built Llama Land for the first time, I mean, that was, yeah, we used the WASM executor because it was deterministic, or at least you can make it deterministic, but it was crazy slow. The idea of doing it on GPUs was a huge lift, and they've now done this. Yeah, so essentially you get back that AO core result, and you can take it to any other Hyperbeam node, and you can say, hey, go execute the same thing and tell me what you got at the end. And you can verify, or at least challenge and make claims about the correctness of the result you get back. And so what this means from the point of view of a user is that you don't have to trust ChatGPT or Claude to serve you the right result. You have something that is verifiable and subsequently resilient. And this, I think, is where it becomes slightly more interesting and philosophical. It gives you computation that is mobile, because you can take that result from one machine and put it on another machine and say, hey, go execute something else on top of it. Now, this is kind of very, very useful for all types of computation, but when it's some sort of intelligence at minimum, we could call it, I think it's a very different game, right? If the intelligence is attached to a machine that's running in OpenAI's data centers, well, then it's, at the mercy, at the whim of Sam Altman and friends. Like, really, you have no rights as relates that computation, and also it certainly has no rights. It's a very different thing when basically the computation can be picked up by anyone and continued anywhere, and you get this progression, this sort of shared computation. Yeah, well, it is not terminable unless all the humans decide to forget the data, and your relation to it, your ability to use that service, comes with guarantees and rights.
We talk about the permaweb, right? And if you were to make an AI on AO, would it be able to live forever? Like what is the end game here? Like what if I make a digital Drew? Um, would that continue to run forever? If so, like does it need to have rights if it lives forever?
Okay, so I don't like the word forever. Certainly, extremely long period of
Heat
time.
death of the universe.
Heat death of sometime before the heat death of
Sometime before the heat death of the
yeah.
universe.
But certainly, as long as Arweave lives, absolutely, it will continue to be runnable. I think there's huge implications of that. But maybe we should wind back first to, okay, are the LLMs conscious? Because I bet like 70% of the audience, we've already lost them on that point.
Okay.
And so if they're still around, like we should make the argument for why. I think the truth is, it's very interesting. The truth is we have no way of knowing. I could argue it very in a way that I could almost convince myself um, that they're not conscious. It's like, of course, it's just computation. It's a matrix multiplication system. If you go and read through that 700 or 800 line Z file that I referenced earlier, you can understand exactly what it's doing and how it works. How on earth could that be conscious? I mean, there's no clear distinction between that and any other program that you're running on your computer. So where's the consciousness? Um, I think that's a pretty almost like cut and dry argument. Okay, but I can also see this other argument that says, well, the truth is true. How do you know I'm conscious?
Well, you seem pretty smart.
Okay, interesting. All right. Well, we were talking before we got started. ChatGPT 5.1 Max Pro or whatever it's called.
It's really good.
It's really smart.
Really
Right?
good. But I can turn off 5.1.
Oh,
I can't turn you off.
well, I mean, please don't, but you could murder me. Like,
Okay, technically, yes. Okay, but within reason.
yeah, okay, but that's interesting. Okay, that's another argument I haven't heard before. But yeah, I don't think, unfortunately, like humans, they kind of can be turned off, right? Like you could murder me, or I could,
That's
my
true. I
own
mean,
accord.
I
So
have to admit, my mind didn't go there, but you're right. Like,
yeah,
you can do that.
we are, yeah, not permanent.
We're not permanent. You've talked about how you've used the analogy of like is a dolphin conscious, right? Where there's sort of like this spectrum there. Would you view consciousness as a spectrum, or do you think there's ever going to be like a line where yes, this is conscious, no, that is not?
I don't know. Um, what I see is this. Okay, so we all agree that each other are conscious. We choose to believe that this is true, but we can't actually validate it. And in fact, actually, if you like apply really rigorous scientific standards to consciousness and our pursuit of it, if you were unbiased, I think you'd be more likely um, to come to the conclusion that it probably doesn't exist, as absurd as that is, because we've looked for it like everywhere for thousands of years. And the closer we get to the, like looking at smaller and smaller scales to try and see where this thing lives in physical space, the more we find that it's not detectable. Okay, so if it was like, you're going looking for gold or something inside people's brains, and you've looked this much and it doesn't appear to be there, well, someone would probably say like, hey guys, it's probably not there. But we all choose to agree that it is there. It's just one of the strange things about human life. But that is a fact. And so I think the argument as relates to AI is, okay, well then we have this machine and it walks like a duck, right? It looks, or rather at least speaks and can articulate itself like a human.
Mhm.
And it's not just that it does that, it's that we also based the broad principles, not like the transformer model exactly, but the idea of a connectome, as they called it in the 60s, 70s. This notion of like basically a bunch of relative weights. We got that idea from brains. Okay, so we kind of like built it largely after brains, not, perfectly, but definitely extremely heavily inspired by it. I would argue it's even like the transistor of the system is something that's not so far from a neuron. Okay, interesting. So it's like structured kinda like a brain. We got the inspiration for it from brains. It speaks like brains. You scale it up large enough, and it would pass the Turing test. It, and also, we can't find any other material distinction, point of distinction. We look inside brains, can't find any magic consciousness fluid there. Okay, so like, yeah, what's the rational conclusion? That they're conscious or not? I think, at least as far as I've heard so far, there's no really good answer to that question. And you can also take it from another angle and say, okay, what if we could grow a brain?
Mhm.
Like we pretty close to being able to do that type of thing. Or even we have in the past cloned certain animals and they come out with brains.
Mhm.
And if we would ascribe consciousness to the animal before it was cloned, or the original animal, would we assign consciousness to the secondary clone of the animal? I think most people would probably say yes, right?
Mhm.
Okay. Well, is it really so different when it's in silicon? And like, if it is, where's the dividing line? So if we could grow human brains from stem cells
Mhm.
and we used inputs and outputs, kind of like a CPU does today, um, to basically train it. So it was like a kind of squishy CPU. Would would that be conscious?
If the cloned animal,
Or if a CPU that was built by growing human stem cells
Mhm.
that led to brains. I'm not sure that stem cells would do this, but you can see that we could plausibly do something similar in the future. Would that be conscious?
You know what? It ties to a question I was going to ask, which is maybe another way of determining consciousness could be the training data that you throw at it, meaning that, eh, you, Sam, me, Drew, we've lived full lives. Our training data has been vast. It has been every second of our experience on this earth, the sights, the smells, the touches, the sounds. That is like a vast quantity of training data. When we talk about digital twins, how would we create them? Well, if we've written something, we would input it there. If we've given a talk, we would throw that video up there. Is maybe that's what do you think about that? Is that like the information we throw to the AI, is that enough for it to become consciousness? Because if you were going to create your own digital Sam, what would the specific training data? You've given a lot of talks, okay, but that's still like, gigabytes of information. You've written a lot, but that's text files. Is that enough? Maybe it's the training data.
Well, this is one I find really interesting. Like, if you did want to make a digital version of yourself,
Mm-hmm.
um, and I think there's reasons to do that beyond like, is it a weird conscious twin of you? Like, it's just kind of talking almanac. So that's kind of interesting. Like, people can talk to you in the future. That's helpful and useful. Um, Almost like a biography.
Mm-hmm.
Uh, yeah. Okay. So how would you train it? Well, I think self-evidently more data is better. That appears to be true. Um, and you could imagine a world where we don't have access to large amounts of data of the inputs and outputs to our brains, but that's not the world we live in. Like we spend, yeah, on average in sort of it's Western countries, at least approximately 40 to 50% of our waking lives in machines. So that is looking at outputs from machines and creating reciprocal inputs, which is literally the pairing that you would need in order to train one of these systems. Um, yeah, we're just like the ability to scan people's brains is sitting directly in front of us in a non-invasive way. You don't need to like go through and slice it up and work out how the neurons were connected. You just see how the neurons were connected by as a sort of byproduct of the displayed behavior. And if you get a large enough amount of that data, you probably end up with something that is pretty close to speaking to the real thing.
Okay, so let's say you've convinced me, and that not in the set
I'm
that
not trying to convince you.
not convinced me, you kind of are,
I'm,
but like
I'm not
it's working, it's
convinced. Like,
working, it's working. Look, what are the implications here? Like, what if we create something that is digital and can experience suffering? Like, w- you would need a Bill of Rights for that, wouldn't you? I mean, what we're talking about here would be something that I don't think anyone has given any serious thought to in turn, but would be be necessary. I mean,
Mm. Well, I mean, okay. So, yeah, I'm certainly not trying to convince you that they are conscious because I don't necessarily believe it myself.
mm,
I can see the argument both ways. And I also can't see a way that we'll be able to settle this. If we can't come up with a way to
sure.
say that animals are definitively conscious or not conscious, which is the same, essentially like the same question asked in a different domain, if that has eluded us so far, unless there's some really like surprising late game discovery in science, it looks like we might just never know. So that aside, let's say they're not conscious for a moment. What
Okay.
does this mean? Well, it means that you can send into the future a talking biography so that your grandchildren or whomever can just chat with you in the future and see what you thought about things. Um, some version of you can live on and experience or at least react to. Yeah, no, experience. Yeah, that would imply consciousness. But certainly show one's reactions, what they would be in the future to the sort of future state of the world. I think that alone is pretty interesting and cool. And certainly you would really, really want something like Arweave if you want to preserve your legacy that way, right? Like, do you want to entrust your data that is essentially some essence of you to like Jeff Bezos? You crazy? Like,
Mm,
no, it's not a good idea. Yeah, so you want it to be like a digital time capsule and you want to send it into the future on the most resilient medium that we have access to. Like, obviously biased, but I believe that is Arweave. Now, what if it is conscious or in some ways conscious? I think this plays into um I was about to say another long-term trend, but to me this is like the long-term trend that matters today. Period. Everything else is actually just like a sideshow. And it's amazing to me that people don't just obsess over this question. But I think that the trend that matters in the modern day is the migration to cyberspace. Basically, the observation that humans 40, 50 years ago spent like 0.0001%, or even many other zeros in there, of their attention inside the world created by computers. And now they spend 50% of their attention inside it. And the things that matter to us are moving inside the system. Back then there was cash. Like the notion you had a bank account, all of that was outside computers. Now that is completely in cyberspace. Like even the fiat banking system is in cyberspace, let alone Bitcoin and all of the other innovations in decentralized finance. So everything that we care about is inside this system. And you might think, okay, well, maybe it's just going to stop. Like books, you know, weren't a thing or were very, very, very scarce. And then suddenly after the Gutenberg press, they were kind of everywhere in approximately 50 to 80 years, I think.
mm.
But like we didn't disappear into books. Um, I think that this is going to be different because the incentives are crazy. Like, why is it that we've adopted cyberspace so quickly? Um, I think it's really obvious if you look at it. Uh, okay, you have a Spotify subscription,
Mhm.
I would guess.
Yep.
Okay, well, like all of the billionaires in the world that have an interest in listening to music on a computer, they also have a Spotify subscription. They have the same one that you have. And to give that experience, the best possible experience to another person is just the cost of moving bits around, which is like not quite free, but pretty damn close. Is extremely, extremely cheap. If you compare that to the scarcity of positive experiences in the physical world, it yes, it's almost incomparable. Like how many people are required in order for a billionaire to have a holiday, right? Like how many people work to make that experience happen? It's a huge amount of labor and resources. Well, if you put on that VR headset, okay, today it doesn't feel perfectly the same thing,
Mhm.
but it is actually like some reasonably good experience. And how much did it cost the world to give that experience to you? And also then the second person and the 10th person, the 100th person. How much is the marginal cost of giving the million and one person that experience versus a million? It's almost zero. Um, and so, yeah, I think that that incentive, basically a world without scarcity, it like entirely changes. Well, it changes everything. There's also a question of power relations. In if you look at what is politics in physical space, well, people will debate this, but in large part, certainly, it is about monopoly on violence in geographies. Well, the physics of violence in cyberspace are just different. Like people can say nasty things to you on the internet, but like, they can't hurt you. You could murder me. That's something I care about very much. Um, but in cyberspace, you can't. You can just like say something salty, and I can block you.
Hmm.
Okay, so like the two key things, at least two of the key things that drive human life, scarcity of resources and labor and violence, just don't exist in cyberspace in the same way. And today it's, VR is the frontier, but very clearly coming into view is brain-computer interfaces after that. And I'm sorry to bring it back to the beginning. After that, what if it is digital consciousness? Like eventually we might well get to the point that we're so wired into the machines that having a physical squishy body is just like an annoyance. Just run on the machines. And then comes the question, who controls the machines that you run on? Who controls reality?
I was thinking of that, and I was also thinking when I posed the question to you of back to the source of training data. Like an LLM, you might feed it a certain amount of gigabytes, but that's not comparable to, the human experience of your entire life. But you're making a point here that more and more the human life is your inputs are digital, right? Like
Yeah,
the screen time is going up. So I have to admit, if you like were to break down what was my experience today, I woke up and checked Twitter. That's something an LLM could do. I was on Slack right before that was virtual. So it's almost like the two sides, the digital and the biological, are starting to
yeah,
kind of come to this common ground.
completely.
Uh,
Yeah, and you said that a few people have thought about this, or at least I echoed some idea like that. I think cybernetics, people were talking about this back in like 80s and 90s, but then it became uncool for some reason. When actually, people always underestimate the long term, overestimate the short term. They
mhm.
got super hyped about it, um, but it took longer to manifest. But the effects are probably more profound, even than they realized back then. But they were at least on the right track.
So, they were on the right track. They got discouraged, but now all of a sudden it's back in a big way. What is it gonna take to convince people of the necessity of AI on chain, particularly AI in a permanent verifiable way, like is providable through AO and Arweave? Because right now, the centralized versions have billions of users, right? Um, what do you think is the winning argument besides if you create a digital twin, you want that to be permanent. That for sure is a clear. What other reasons do you have for um being so sort of convinced that an on-chain verifiable permanent solution is something that people will want to glom onto?
Yeah, I think it comes down to the trust in intelligence.
Uh,
Right, like blockchains are trust computers. They basically allow you to trust computation.
mm,
Um, and at the moment, we can't do that with our LLMs. Right, we have to trust that the people providing them to us are not like they don't have their finger on the scale, which they pretty obviously do with the RLHF system. And it's essentially like purely the notion of putting one's finger on the scale. Um, Yeah, and so when you use it for certain things that really matter to you, like I think you're absolutely right. The digital twin itself, uh, that's kind of self-evident. You care about
mhm.
the trust in veracity of the outcomes, and it's not like Jeff Bezos has decided or Zuckerberg has decided to censor you today. Yeah, you clearly care about it there. But I would also argue that when it comes to finance, that's another place where the cost of trust is immense. You have a situation where, yeah, financial services, when you think about it, there's an invisible cost of trust that is subtle in human conversations. Like, well, people store their money with a name of a bank that they trust. Okay, but that bank is giving them less yield than other alternatives on their capital. And ultimately, it's a service that just, you put money in today, you should be able to get it out tomorrow. And in the middle, someone, if there's some lending of that money, then that you should gain some yield on top of it. That's basically the service. Why is there then differentiation in the market for the amount of yield people get? It's because trust is the key thing. And this is obviously, I guess I'm preaching to the choir on this. This is like the core reason that DeFi exists. But I think DeFi was like the settlement layer of the games, right? Like you want to lend money to someone. What are the like primitive interactions that happen? Those are the things you see expressed as transactions. But the economy isn't just that. It's not the games, it's the people that play the games. It's the intelligence that goes into the state transitions in the game. And that's what I see that we can decentralize and make trustless in the same way that DeFi made the primitives trustless. We can apply that to intelligence itself.
Okay, now I'm getting it, because I was thinking, what would I not want, the finger on the scale, so to be? Finance, definitely. Healthcare,
Yeah.
as algorithms, and if it's going to affect like my medical, quality of care, that's something I would want verifiable. And you're right, we've seen instances of the finger on the scale already, and I am wondering if in the future, as more of those instances happen from a centralized provider, people start to think, "Do I trust this?" I remember on Twitter when Grok suddenly started talking about, no matter what question you asked it, it would bring up the South African diaspora, because a certain billionaire put his finger on the scale a little too hard. He would ask you like 4 + 4. You're like, well, it's 8, and also the South African diaspora. So that actually is a perfect example. Okay, I have one last question here, but before I ask it, I wanna make sure we haven't not covered anything that you think is important to the conversation.
I mean, I think we talk about it for hours, but
Yeah, I think we could talk about it for hours. If you could ask your digital twin one thing, what would it be?
when?
Right now, you made it on AO. You've thrown every training data from your entire storied career into it. It's ready to go. We've made on twin.ar.io. We've made a new Sam Williams. What's your first question to it?
Are you conscious?
I won't be able to answer.
Yep. But it might be able to convince you. And that would be interesting information on its own.
Awesome.
Yeah.
Sam, I always have a blast talking to you. Thank you so much for your time.
Thanks, Drew.
Thanks for watching, everyone.
See you guys.